So we have to add the two rational expressions, the one that's here with that one. And by the looks of it, it seems as though they don't have anything in common, but we can identify common terms if we're able to come up with common factors. So a squared plus 2a plus 1, if we factor it, it is a standard factor. Expression, which is a plus 1 times a plus 1, which if you FOIL, you'd see you would get a squared plus 2a plus 1. And the next one is a squared minus 1, which is a special product. So that would simply be a plus 1 times a minus 1. So we have a plus 1 in common between the two expressions. So in our LCD, we need a plus 1. And there is another a plus 1 and a minus 1. So we don't have anything in common, so we just have to write them as is. So I could rewrite the first factor as 2 divided by a plus 1 squared, and the second expression as 3 divided by a plus 1 times a minus 1. So our common denominator is a plus 1 squared multiplied by a minus 1. So in the first denominator, I have a plus 1, a plus 1. In the second denominator, I have a plus 1 times a minus 1. Going back and looking at the LCD, for the first denominator, I see a plus 1, a plus 1. What's missing? I'm missing a minus 1. So I multiply and divide by a minus 1 to get the LCD, a plus 1 times a plus 1 times a minus 1. In the second denominator, I have a plus 1 times a minus 1. So I'm missing a plus 1. So I'm going to multiply and divide by a plus 1. So now I have a common denominator, and it doesn't matter how you want to write that, because some people would like to write it as a plus 1 whole squared multiplied by a minus 1. Some would like to write it as a plus 1 multiplied by a squared minus 1. That's just how I like to write it. So all I have to do now is combine the numerators. So I have 2 times a minus 1, which would give me 2a minus 2. In the second numerator, we have 3 times a plus 1. That would give us 3a plus 3. So 3a plus 2a is 5a. 3 minus 2 is 1. So we have 5a plus 1 divided by a plus 1 times a squared minus 1. So this is an easy problem. So we have x plus 1 in the first denominator. So x plus 1 is just x plus 1 as is. There's nothing we could do about it. The next one is 3x plus 3. I could write 3x plus 3 as 3 multiplied by x plus 1. After that, we have 2x plus 2, which I could write as 2 multiplied by x plus 1. So what do we have in common among the three denominators? We have x plus 1, x plus 1, x plus 1. So when we write the LCD, all we need is 1 x plus 1. In terms of the numbers, I have 1, 2, and 3. And there is nothing in common between 2 and 3. So we just have to multiply the 2. So we would have 6. So if we go back and rewrite each expression, I could write the first rational expression as 2 over x plus 1. The next one, 3x divided by 3 times x plus 1. I'm pulling the 3 out. The last one, 1 over 2 times x plus 1. Some would like to cancel the 3's right away in the middle rational expression. That is fine, but we don't have to do that. We can simplify it at the very end. So the least common denominator is 6 times x plus 1. And in the first rational expression, I am missing a 6. So I am going to multiply and divide by 6. The second denominator has 3 times x plus 1, but I need 6 times x plus 1, so I multiply and divide by 2. So 3x times 2 is 6x, divided by 3 times 2 is 6 times x plus 1. And the last rational expression has 2 times x plus 1 in the denominator, and I need to have 6. So I'm going to multiply and divide by 3. So 3 divided by 2 times 3 is 6 times x plus 1. So now we have a common denominator, and that common denominator is 6 times x plus 1. So I can combine the numerators. So 12 for 6 times 2 minus 6x plus 3. Which would give us 15 minus 6x over 6 times x plus 1. A 3 is in common between 15 and 6. So if I pull the 3 out, I have 5 minus 2x divided by 6 times x plus 1. We can cancel the 3 and the 6 to get 2. So the final answer is 5 minus 2x divided by 2 times x plus 1. Okay, so we have 3 rational expressions. The idea is the same. Find the least common denominator. So the first one is x squared minus 9, which I could write it as x plus 3 times x minus 3. The next expression is x squared minus 6x plus 9 in the denominator. That simply is x minus 3 times x minus 3 if you factor. And the last one is just x plus 3 by itself. So there's nothing we could do with that. So the least common denominator, if we go back and look at the common term, we see an x plus 3 there and there, but it's missing in the second term, so we need to have x plus 3. We have an x minus 3 in common between the first two denominators, missing in the third one, so an x minus 3 has to be there. And if we look at the second term, second denominator, it has an additional x plus x minus 3. Not only that, the second denominator is x minus 3 squared, which is missing entirely in the third denominator. So the least common denominator has to be x plus 3 times x minus 3 times x minus 3, which would give us x plus 3 multiplied by x minus 3 squared as the least common denominator. So if we go back and rewrite each term, we will have x divided by x plus 3 times x minus 3 plus 3 divided by x minus 3 squared minus 1 divided by x plus 3. So we have x plus 3 and x minus 3 in the first denominator. I'm missing x minus 3, so I multiply and divide by x minus 3. So since I have x minus 3 already, when I multiply by x minus 3, I end up getting x minus 3 squared. In the second denominator, I have x minus 3 parentheses squared. I'm missing x plus 3, so I'm going to multiply and divide by x plus 3. So I end up having x plus 3 times x minus 3 squared in the denominator, which is the least common denominator. In the last denominator, I have x plus 3. I'm missing x minus 3 squared, so I multiply and divide by x minus 3 squared divided by x plus 3 times x minus 3 squared. So we now have a common denominator, which is x plus 3 times x minus 3 squared. First numerator is x times x minus 3. I can distribute the x because I'm trying to simplify at the same time. So x squared minus 3x. I can distribute the 3 in the next numerator. So I have 3x plus 9. Let's not skip a step with the last one. So I have minus. If I FOIL x minus 3 times x minus 3, I know that we're going to get x squared minus 6x plus 9. So we have x squared minus 6x plus 9. So the denominator is x plus 3 times x minus 3 squared. The 3x and 3x will get cancelled. We have x squared plus 9. Distribute the negative. I have minus x squared plus 6x minus 9. The x squared would go away. The 9 would go away. And we simply have 6x divided by x plus 3 times x minus 3 squared. Now, as I mentioned in the previous problem, some like to write it that way. Some may prefer writing it this way, but either way, the answer is the same. So it's just going to depend on how you want to multiply things. Some would simply say, I want to write it as x squared minus 9 times x plus 3. Others, x plus 3 times x minus 3 squared. It is a matter of choice.